With a method called acceptance sampling, a sample of items is selected without replacement, and the entire batch is accepted if the entire sample is okay. So a company has just manufactured 1,191 CDs, I'm missing the word CDs, and 213 of them are defective. If 3 of these CDs are randomly selected, what is the probability that the entire batch will be selected? Well, we're sampling without replacement, which means when we sample, we have to treat the samples as being dependent. However, we should check that we can use the 5% guideline, which may tell us that we can actually treat these as independent, even though we're sampling without replacement. So the 5% guideline says that if our sample size, which is 3, is less than 5% of our entire population size, then we can treat these as independent. So to check that percentage, we divide our sample size 3 by our population, and in this case we get 0.002, which is less than 5%. So we can actually treat the samples as being independent. Now to find the probability of A and B and C occurring, where A is the event that we pick a CD that is good, and B is the event that we pick a CD that's good, and C is the event where we pick a CD that is good, the probability of A and B and C occurring, since we can treat these as independent based on the 5% guideline, is the probability that A occurs times the probability that B occurs times the probability that C occurs. Now to calculate the probability that A occurs, we have to be a little careful. So we know in our batch that 213 out of 191 CDs are defective. What we have to figure out is how many are not defective in that batch and divide that by the 1,191. That is 1,191. Well, if there's 1,191 CDs and 213 are defective, simply subtracting those, that is 213 from 1,191, we get that there are 978 that are not defective. So the probability of reaching into the bag and pulling out a CD that is good is 978 divided by the population size, 1,191. Of course, since we're treating the event B as being independent as well as the event C, they will all have the same probability. So each one has a probability of 978 divided by 1,191. If you're wondering if there's an easier way or a shorter way to write this, of course there is. We could just say that's 978 divided by 1,191 to the third power. A quick, entering this into our calculator, quick calculation shows that the probability that the entire batch will be selected is 0.5537, or a greater than 50% chance that the batch will be selected.